In this lab, we are going to simulate on-premises HPC cluster. To simulate a hybrid environment, we will deploy an external Slurm cluster that is not initially managed by Cycle Cloud. To simulate this on-prem environment, we are going to create two VMs. One is for the scheduler, another one for compute, and we will deploy this VM in an on-prem network that we created. And then we will create a Slurm cluster using some scripts, which I kept it in the Git repo. Let's get into Azure portal and then start creating the VMs. So I'm going to create a VM. Resource group is HPC demo and VM name is scheduler. Not keeping any availability soon. Selecting Ubuntu HPC 2204 as the image. And I'm going to select the 4S v5 VM SKU for scheduler. SSH key. I have an SSH key from my machine. Let me copy that, add it here. And disk we are not touching. The network, we're going to choose this on-prem network and select the default. Subnet. That's all. Click review and create. So deployment started. In the meantime, let's create another VM, HPC demo. I'm calling this as compute one. I'm selecting the Ubuntu HPC 2204 as the image. I'm also keeping the same D4SV5 machine for compute. Same SSH key. In the networking, let's select on-prem. That's all. Let's hit create. Now it's creating the VM. Yeah, we can see that. Let's go to the scheduler VM. Port number 22 is enabled. Let's try login. We have logged into the scheduler. Let's go to the compute node. Let's check the network. Take the public IP and log into the compute node. We have successfully logged into scheduler and compute node. So this is the Git repository which I created, and I place some script for deploying the hybrid HPC environment. So I have few helper scripts. So there are different directories like compute, cycle cloud, scheduler, and test. The scheduler directory has got the script for building the external Slurm scheduler. The compute node directory has the script for building the on-premises compute node. And cycle cloud directory has some script for deploying the headless cluster and then look into the integration, etc. We will get to there once we started working on it. So let's clone this repository on scheduler, switch to root, do git clone, cd to cycle cloud hybrid HPC lab directory, and then go to the scheduler. We are on the scheduler VM, and let's go to the scheduler. And we have a script called as slum scheduler builder.sh. So this script is going to set up uh, the configuration, do the installation of Slum, configure the Munch user, Slum user, and also setting up an NFS server where we are going to have the central home directory. So I'm not using an external file system here. From the head node, I am taking a directory and export it to other node for keeping the central home directory, and then installing the packages, and then creating the slum.conf file. And at the end, I'm also adding a DNS, the one that we created, the domain hpc.internal for the naming resolution. Yeah. So let's execute it. So the cluster name, which we are going to use it uh, on the cycle cloud, but let's call it as a cluster name that we are going to build it. So I'm calling it as demo. The Slum version, so I'm using this 24.05.4, and this is the same version that we have in cycle cloud. So I'm keeping the same version on this externally managed cluster. If you input these two, it'll start creating everything automatically. You can see it's created the Munch and Slum user. It set up the NFS. Now it is going to install the Slum and then do the configuration. Just to ease out the things, I just configured everything, put it in a script so that we don't have to go through each and every step. In case if it failed, we don't have to look for troubleshooting. So everything is like automated. So the setup is finished. We can see it's configured Munch, it configured Slum, and then we also get the IP address which we need to use it on the cycle cloud as well as on the compute node. So I exported these two file systems, /shared and /sked. /shared is where the home directories I'm going to keep. Sked is the place where I'm going to keep my configuration file like slum.conf, munchkey, and other configuration files. And this is actually a link to the etc slum.configuration file so that it is centralized, so all the compute node can use the same configuration file, so I don't have to copy everything manually. Now let's go to the compute node and do the same thing. Go to the compute node, switch to root, do the git clone, cd to the directory, cd to compute node. So this is a compute node. So let's go to the compute node directory. Let's execute. The 01 compute node is. So we have to give the same cluster name, say demo. Slum version, we're going to use this exact same cluster version, and it is asking for the IP address of the NFS server, which is the scheduler. So we have it here. Keep that. So now it will mount the NFS share from the scheduler. It will also create the group for Munch user for Munch and Slum. And install the Slum binaries and use the configuration. Let's start the Slum CTLD. The Slum CTLD service is started. Now I have another script. It's called as partition. So this is the one that I created for the compute node. The compute one, the one that we have, and the partition name is on-prem. Let execute that. So this will add it into our partition configuration file. On the compute node, these two exports are mounted, and we can check the etc slum directory. It's all connected. Now let's start the slumd. Slumd started. I just added the partition configuration. So let me do scontrol reconfigure. Now let me run sinfo. So I have an on-prem partition and I have one node, say compute. I don't have a centralized authentication mechanism. So let me use this particular script for creating a local user. I'll keep this for now. I'll test a job using srun -p on-prem hostname. So the job run, it executed, uh, returned the hostname of the compute node. So the slum is working. So we finished setting up the on-premises